platform enilethulelwa ngezilokotho ezinhle Ithala kanye neGo Digital SA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology kanye namaklasi e-learner wellness okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu kuqala ngehora lesi-4 kuya kwelesihlanu u-4 kuya ku-5 ntambama nangoMgqibelo kusukela ligamanxe ihora lesi-8 8:30 kuze kugamanxe ihora lokuqala emini 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi Go Digital SA_movement noma kwi-YouTube uthi Go Digital SA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani bafundi, sehlangene futhi kwi-physical sciences, Mr. Mbayi. Lona namhlanje sikhuluma nge-electric circuit. Into sazi kahle ukuthi nayiqala ka grade 9 ama-electric circuit noma ka grade 8. Akuhlukile nalokho senakwenza ka grade 8, grade 9, grade 10, grade 11. Uthi ka grade 12 si-edda nje into encane eyokuthi internal resistance. Kodwa namhlanje so khuluma nge-electric circuit, just introduction yakhona. Now, talking about electric circuit, for a setup to be called electric circuit, ifanele ube nani, a source of electrical energy. The source of electric energy kasebenzisa i-battery or i-cell. A symbol ye-cell or i-battery can be like these two lines. This represent what? A cell. When you have too many, then it becomes what? E-battery. So this one is a battery of cells. Njengobona ngala, it's a cell, just one cell. This is a battery of cells. So ungabona ukuthi ama cells angamangaki lana awu 3. So you have 3 cells here, right? So it's a battery of cells. Now, the next thing, ifanele ukukhumbula ukuthi when you have the source of electrical energy, we also need to have the setup where the energy will be converted, electrical energy to be changed into another form of energy. Galapho sebenzisa ungaba ne light bulb noma ungaba ne resistor or something like that. Right. So that is where electrical energy izoshintsha from another form of energy. Masebenzisa light bulb siyazi ukuthi izophenduka light energy. We have a resistor that can heat up, so shintsha electrical energy into heat energy and so on. Masebenzisa fan, for example, yakushintsha electrical energy into mechanical energy. So you have different types of energies that can be got from the electrical energy. Beside that, udinga futhi in a conductor or a medium through which the electrical energy will be transferred. Ukuze isukela kwi source of electrical energy is a figure where energy izoshintsha to another form of energy. So we use what? A conductor, an electric conductor. That can be what? A wire, right? An electric conductor, right? Ne resistor still, it's also what? An electric conductor. Any electric device, as we say in society, will be at this point in time, so ibuga as if it is a resistor, right? Now, in the electric circuit, quantities that will be involved, such as a potential difference, a potential difference. A potential difference ibiza futhi ngani voltage. Voltage. Potential difference. So this one can be defined as the energy per unit charge, the amount of energy transferred per unit charge. Potential difference because formula a symbol yakhona to V, then masithi energy per unit charge to W over Q, where W is the energy in joules, then Q, that is the charge is in coulomb. The charge is in coulomb. So a unit yakhona as for a voltage, a unit voltage ubani, due to the fact that a formula it W over Q, then soti a unit voltage ubani joules per coulomb. Yoni unit ye voltage. This one sibiza nge compound unit ye voltage, then ilo joules per coulomb kwa vele wabizwa ngani nge volts. So the main unit esosebenzisa will be what? The volt, right? So we can say that 1 volt it's simply equal to 1 joule per coulomb, right? The unit voltage, right? So that is the first quantity SNI voltage, right? Now the second one singakhuluma ngani electric current. The current, very important, the electric current. We have the current. So the current is defined as the charge or the rate of flow of charge. Current will give it a symbol I, is the rate of flow of charge, Q over delta T, right? The charge passing a point in 1 second. That is the rate of flow of charge. That will be the current. So moibuga ngala, a charge is in coulomb, iskati delta T is in second. So the unit for the current ubani, looking at the formula, it charge per unit time. So charge is it's expressed in coulomb, the time is in second. So the unit the current will be coulomb per second. This is the this will be the compound unit current. This compound unit current was called the amperes or amps. This amperes. So this will be the unit SO7. So we can say 1 amp is simply 1 coulomb per second, passing a point in a second. That is the compound unit, the current. The next quantity, so kulumanga resistance. A resistance is just an electric conductor, but can resist the flow of the current. A resistance is simply defined as a resistance to the flow or the opposition to the flow of current, right? This opposition to the flow of current. For your information, a resistance is just depending on the nature of the conductor. Kungaba aluminium, noma kube copper or something, then you know ukuthi copper doesn't have the same conductivity as aluminium. Kia depend futhi with the length of the conductor, then inversely proportional to the area of the conductor. So when you have a big conductor, a thicker conductor, it represents what? A smaller resistance. This is just for your information. So masibu aganje singatini. In terms of a resistance, the unit for the resistance will be the ohms, right? The symbol is the omega like this to represent what the ohm. So here's a relationship between a current, resistance, and the potential difference, right? So sibuke leo relationship, right? The relationship a corner between current, voltage, and resistance, right? So in an electric circuit, you'll see that you have a current, you have a voltage, also have a resistance. Now, into says you got voltage we told we cell battery that you have, then the resistance is the conductor. The main factor that depend kulaba two voltage ne resistance will be the current. So into soyibona ukuthi i-current will be directly proportional to the voltage. So ukuthi ma i-voltage enkulu, the current will also be big, like as current is directly proportional to the voltage. When you increase the voltage, the current will also increase. Then at the same time, the current is inversely proportional to the resistance. This means that if you have a greater resistance, the current will decrease. Remember, the definition still resistance is the opposition to the flow of the current. So putting this together, so till I is equal to V over R, right? So that is the main formula esiyisebenzisa. I is equal to V over R. So from there, we can now work out, derive other formula. Got you to V is equal to I times R. No masifuna R, so to R is equal to V over I, but all coming from the same formula. Asibuke my electric circuit, because that is the main thing. How do we represent a simple electric circuit? Right, with the simple electric circuit, so toluguti sine cell, and then hlambe singaba ne switch, then kube resistance, then ibuyele ngala. Right, now why do we have a flow of current ngoba kune difference in potential kule voltage kule cell here? No, positive kuno negative. Ama electrons azosuka ngala. Then when the switch is closed, azohamba adlule ngala ku resistance, the same number of electrons that were left, the cell will be the same number of electrons going back to the cell. So I current puma ku cell, same current ebuyela khona ku cell. So if 10 amps leaves the cell, 10 amps will come back to the cell. Here it will just be what a transformation of that electrical energy into another form of energy. If, for example, machina voltage hlambe 3 volt, resistance ibe hlambe 10 ohms. So uzobona ukuthi voltage we have is 3 volt, resistance 10 ohms. But for calculate current, so I is equal to V over R, then that will be 3 over 10, and 3 over 10 give us what? Or 0.3 amps. That's how we calculate the electric current in a second. Right. Now, ngenzeka futhi bakuniki current, then bafuna ukuthi uthole voltage, again is the same thing that you use. Khona izinto sosebenzisa ku electric circuit ama instrument azosiza ukuthi si measure i-current noma i-voltage. So measure i-current sebenzisa i-instrument called the ammeter. It's over like a symbol, it ammeter A there, and then sibene voltmeter. Into fanele uyaziyo ukuthi ammeter is connected in series and the voltmeter is connected in parallel, noma sothi across that resistor. And njalo mawubuka is electric circuit ungayinaki i-current i-ammeter or i-voltmeter, we always assume ukuthi i-ammeter ngoba i-connected in series, it has a very small resistance, so a negligible resistance. And if voltmeter ngoba connected in parallel, so we'll assume that it has a very big resistance. So in this circuit, uma ngifuna measure current, I just need to break this circuit and then ngifake ammeter. Right? So you see that it is in series with in series in the circuit, so it measures the current. Kodwa ngifuna ukuthola voltage across R, so we connector in parallel. This is how you connect in parallel or across that one. Right? Then that is a simple electric circuit. That you have that. Now kungenzeka ukuthi ube nama resistors out 2 or 3, then you have to do what is set up. We have two ways of connecting ama resistors. Unga connector in series noma wa connector in parallel. Then uzobona ukuthi i-behavior a series circuit ayifani ne behavior a parallel circuit. Right? Let's have an example. Right? A series circuit. Inofanele uyazi nge series circuit. Let's say an example of two resistors. I have R1, I call it R1, then I have another one ngibiza ngo R2. So we have that one will be a series circuit. Then sebenziseni parallel circuit. Parallel circuit. With the parallel circuit, I still have the cell here. Then I have one resistor with R1. I have another resistor with R2. Then connected to the cell. Right. Let's look at the difference between the two. Into siyaziyo ukuthi from this cell kusuka i-current eyodwa, the same current will come back to this cell. Same thing happens with parallel circuit, right? The same current that leaves the cell is the same current that goes back to the cell. Now, for you understand that the current isuka kwi-positive terminal of the cell, then izohamba ihambe to the circuit, iphinde ibuye ngala. So with series circuit, what you see is that the current izohamba through R1 izofana ne current hamba through R2. But masibuka i-parallel circuit, yabo le current izosuka la mayifika la kuni junction, so iya splitter, there will be part of the current izoya ngala through R1, kube ne part of the current izoza ngala through R2. Kodwa ekugcineni kuyahlangana futhi at this point the same current iphinde izela. So if kuno 5 amps ozayo osuka kwi-cell, mase kufika la mhlambe ngala kuzohamba 2 amps, ngala kuhambe bani kuhambe 3 amps. So at the end, at this point, mase kuhlangana futhi is gonna be 2 plus 3 nige futhi 5. So the same 5 izobuyela kephi kwi-cell. That is the this parallel circuit as compared to the series circuit. Now, enye to siyaziyo ukuthi the current that is withdrawn from the cell, it always depends on the resistance. So this cell here does not check ukuthi lana kuna ma resistors out 2. So it will take all these resistors as 1. Then kufaneleke si calculate thina ukuthi makuhlanganisa R1 no R2 kuzophuma into enjani. Lento siyibiza ngani nge total resistance of the circuit. Maku in series, total resistance yahlanganisa so to R1 plus R2. Value add R1, the value ka R1, add the value ka R2. Maku in series. Now in series, if utbona kanjani ukuthi the resistors are connected in series. Hlambe ngathi le resistor ino input ne output, input no output. Makuthi input, output ye resistor yokuqala is connected to input resistor esibili, then you have those two resistors connected in series. Kanti kwi parallel, so ukuthi input ka R1 is connected to input ka R2. Lento intambo eyodwa nje just connected the two resistors. So then you know ngoba kune split of the current, then there is a parallel circuit. Again, singati futhi kuma series circuit, there is only one pathway for the current. The current izohamba la phela. That is why we said that the series circuit, there is only one pathway for the current to flow. Kodwa ku parallel circuit, khona indlela eziningi, so you have many pathways, 2 or more pathways for the current to flow, then you have a parallel circuit. Manje total resistance ye parallel circuit sithola kanjani? Yona ithola ngokuthi ucalculate inverse ye total resistance is equal to 1 over R1 plus 1 over R2. Inamba ozoyithola la it's an inverse of this one. At formula fanele usebenzise ile. Then at the end, mawufuna ukuthola i-value ye resistance. Kunendlela eziwu2. Mazu2, you can do 1 over R1 plus 1 over R2 bese uthi bracket to the power -1. Ukuze izokuphenduleka ukuthi lo 1 over RT abe RT. So ufake bani -1 to the power -1. It will give you what the inverse. Noma mungayisebenzisi leyo ndlela ungasebenzisa bani product and sum. Right, the RT kwi parallel. And so abona it's no longer 1 over RT, unlike here. Site 1 over RT. So the RT product over sum. So the product R1 no R2 over R1 plus R2. Lento le sebenza for 2 resistors only. Right? Mona ma resistors or 3 or 4. This is the one that ungayisebenzi so tholebani i total resistance of the circuit. right? That is one thing about connection in series in parallel. Now enye into sifane siyibuke ukuthi in series the current is the same. I-current izohamba ku-R1 ilingana ne-current izohamba ku-R2 ilingana futhi ne-total current of the circuit. So singathi total current ifana ne-current in R1 iphinde ifane ne-current in R2. That will be different kubani kwi-parallel circuit ngoba kwi-parallel circuit now sobona ukuthi i-current engenayo kule junction, right, inkulu kunala ma-current awu-2 because it is split. So zothi total current is just a combination ye-current hamba ku-R1 ne-current hamba ku-R2. So it's the sum of it. So singathini-ke ukuthi the parallel circuit divide i-current ingakho izobizwa ngani a current divider, right? So the parallel circuit is a current divider ngoba i-divider i-current. Kodwa kwi-series circuit the current is the same. Now asibukeke i-voltage. I-voltage ma une-voltage uzobona ukuthi kule resistance into siyaziyo ukuthi i-current iyalingana ku-R1 iphinde ifane no-R2. But if R1 no R2 banama value angafani, then uzobona ukuthi around R1 sengiyayazi i-current ngiphinde ngazi ini i-resistance. So anything ifanele ngiyenze ukuthi because I know the relationship between u-I, u-R no V, every time mangina u-I no R ngakwazi ukuthola u-V, noma ngino R no V ngakwazi ukuthola bani u-R u-I, noma mangino I no V, I can still get what? R. So it's always about that. So mangibuka le resistance, for example, ngiyazi ithi current ihamba through R1. So the current times lo R1 uzonginika bani i-voltage it is. Ngala i-current times the resistance will also give me what? The same another current. Then I can get what? A voltage. Right. So asithi kwenza i-example, a practical example kwi-series circuit so that sobona ukuthi sithola into enjani, right? Now sithi u-R1 mhlambe une value ka 6 ohms, just an example. I-cell yethu mhlambe no 9 volt, then sibe no R2 u-R2 mhlambe abe 4 ohms, just an example, right? Now into soyibona ngala ukuthi first thing masifuna ukuthola i-current fanele sihlanganise bani lama resistor awu-2, and ngoba in series i-total resistance will simply be calculated as R1 plus R2. So kuzoba u6 plus 4 sekunika bani 10 ohms. That is the total resistance. Kusho ukuthi le circuit lesilula kanje in a sense that unga replace lo 6 ohm no 4 ohms with what? A 10 ohm resistor. Isinika bani RT. Kachate kuba njena. So you still have 9 volt. So this R1 or R2 nakusebenza as a single resistance. So kahle total resistance inga define as a single resistance that can replace the other resistance and have and withdraw the same current. So kuyafana ke i-cell ibona ngathi kuno 10 ohm, ayibona u-R1 no R2 vele kuhlanganise konke then ikunika bani total resistance, that is 10 ohms, right? Masithola total resistance kusho ukuthi siyakwazi ukuthola bani i-total current. I-total current in the circuit izoba i-total voltage over the total resistance. In our case i-total voltage u9, i-total resistance u10. So ithola bani u0.9 amps. That is the total current in the circuit. Njengoba lama resistor in series, it means i-current izohamba ku R1 u0.9, izohamba ku R2 u0.9 still, right? Mase sibuyela ngala. Into siyazi ukuthi khona 0.9 amps ohamba through R1, khona 0.9 amps ohamba through R2 ngoba lama resistor u2 are in series, and we say ukuthi in series the current is the same, right? So in that case sibona ukuthi around R1 sesinayo current, sinani futhi sine resistance. So every time a current ne resistance, so that sino current 1 a resistor 1 u6 ohms siphinde sibe nani ne current ehamba through R1, so ubani u0.9 amps. Ngoba sine resistance and current, we can get what? I-voltage asibize kubani u-V1. Ithini voltage across u-R1. Then siyazi ukuthi voltage will be the product of the current and the resistance. I-current u-0.9, i-resistance u-6. So masenza 0.9 times 6 sola bani 5.9 volts. Right, yoni voltage across R1. Then asiphinde calculate voltage around R2. Ngoba siyazi voltage i-resistance R2 and the current that passes through R2 siyayazi ukuthi 0.9. So singathini, let's calculate uV2. uV2 izoba i-current to R2 times resistor 2. I-current to 0.9, resistor 2 u4. So masenza bani u0.9. Masenza u0.9 times 4 so about 3.6. Unika about 3.6 volt. Right. So sibona ukuthi i-voltage ka R1 u5.9, 5.4 volt. I-voltage ka R2 ubani u3.6 volt. Right, that is the voltage, 3.6. Mawuthi sihlanganisa le voltage R1 V1 no V2, right? Masithi uV1 plus uV2 soba nobani 5.4 plus 3.6. Lokho kusikhiphela bani u9 volt. Masibu u9 volt usibuyisela ngala kwi total voltage, the voltage of the cell. So ngamanye amazwi sothi ukuthi le total voltage here was divided among R1 no R2. That's why a series circuit will be referred to as the potential or the voltage divider. A voltage divider. Right. So a voltage is divided among resistors that are in series. For a parallel circuit, it's a current divider. The total current is divided among resistors that are in parallel. Right, that is one thing. Now, enye into fansibuka ukuthi kungenzeka ukuthi i-total resistance ishintshe masi add ama number of resistors noma siwanciphisa, for example. Right, total resistance yama resistors in series. Right, sifake R1 sithe u6 ohms, lana sithi R2 sithe u4 ohms. What if si add any resistor hlambe sothi 5 ohms, right? Simbizi ngo R3. What's gonna be the total resistance of this circuit? Into siyazi ukuthi in series total resistance hlanganisa wonke ama resistors of R1, R2 plus R3. So uzobo 6 plus 4 plus 5 lokho sikhiphela bani u15. Siyabona ukuthi masina 2 resistors, ama resistor u2 sinasola bani u10. Masi add esithathu i-total resistance iya increase. So singathini, as you add the number of resistors in series, the total resistance increases. Right, the total resistance will increase. Asibona ukuthi kuzokwenzekalani masenza si add ama resistors in parallel. Right, initially asiqale no R1 no R2 sebenzisa same resistors, lo uno 6 ohms, lo una 4 ohms. Right, connected in parallel. Right, sithe total resistance of the circuit in parallel, so T1 over RT is equal to 1 over R1 plus 1 over R2. So lokho kuzoba 1 over 6 plus 1 over 4. This is it, 1 over RT. Then gite earlier on masifunu RT sivele sithi at 1.6 plus 1 over 4 all to the power negative 1. Then izoskiphela bani i-total resistance. So we have 1.1 over 6. That will be skipela 2.4. So we have 2.4 ohms. That is the total resistance alama resistor awu-2 when they are in parallel. Right. Noma mungafuna ukusebenzisa leyo ndlela ungasebenzisani uthi RT is equal to R1 times R2 over R1 plus R2. Lena ngibize ngani product over sum. So that will be 6 times 4 divided by 6 plus 4. Kuzoba 24 over 10 and ukipela bani 2,4. Now, what if si add a resistor esithathu or in parallel, so that we know the total resistance izonyuka noma izoncipha in terms of magnitude, right? Then sinani sino R1 usawu 6 ohms, sino R2 usawu 4 ohms, asi-add-ke u-R3 u-5 ohms. Siya-add-ke u-R3 ngala. Then sifuna ukubona ukuthi kuzokwenzekalani in terms of total resistance. Right. Now, in this case, still, siyazi ukuthi in total resistance, calculator is 1 over RT. That will be 1 over R1 plus 1 over R2 plus 1 over R3. So this will give us 1 over 6 plus 1 over 4 plus 1 over 5. Then, ukuthola RT, so pinda lento, sithi 1 over 6 plus 1 over 4 plus 1 over 5, konke sithi to the power -1. Then, masebenzisa i-calculator. So thola ukuthi we have 1 over 6 plus so thola 1,6, 1 over 6 plus 1 over 4 plus 1 over 5. So all this to the power of negative 1. When 7, so the power -1, asibona ukuthi uzokhiphela bani kule calculator. Calculator tini 1 over 6 noma singathini 1 over 6 plus 1 over 4 plus 1 over 5, then give her 0,616, then so T1 over 0,616, 1,62 ohms, right? So it also told ukuthi the initial makuna 2 resistors sinobani sino 2,4 ohms, but masi add I resistor starts no 1,62. So it also notice ukuthi I total resistance yani ya decrease. So we can see ukuthi we can have a conclusion ukuthi mau add ama resistor in parallel, the total resistance ya decrease. Kanti the total resistance has an impact to current. Remember ukuthi say current is inversely proportional kubani ku resistance. Right, the current is inversely proportional to resistance. So if you add you increase the number of resistors in parallel, the total resistance decreases. If the total resistance decreases, the current increases. Kunjalo. Then the practical information ungayisebenzisa maybe from home as well. Uyazi ukuthi masu plug stove, plug kettle, ufake nani the more you add ama resistor in parallel. Add in parallel. More add in parallel kusho ukuthi total resistance enzani iya decrease. As the total resistance decreases, current izo increase. Then uzobona ke main switch izowa ngoba usu ne current enkulu ukuthi engayishisa nje indlu yonke. So you have to protect your circuit so that if there is a high current, it can be protected, right? So that is for a resistance in series and in parallel. But kwenzeka futhi ukuthi ube nama resistor hlambe awu 3 or more. When you have 3 or more resistors, you have 2 or 3 possibilities that you can connect lama resistor. The first one, ungawafaka wonke in series, or secondly, ungawafaka wonke in parallel, or thirdly, ungasebenzisa kube i-series kodwa kube awu 2 are in parallel. Ngithi ngisebenzisa ama resistor awu 3 and I have 4 options. Manginama resistor awu 3, I have 4 options. Womathathu ungawafaka in series, noma womathathu ngawafaka in parallel, noma ngithathe eyodwa ngithi in series, lawa awu2 ngenze abe in parallel, noma ngithathe u1 abe in parallel with the other 2 in series. Ngiyathemba niyayizwa lento engishoyo ngoba ngikhuluma ngama resistor awu3. So the first one ngathi R1 abe in series no R2 abe in series no R3. Right, that is the first connection. Yesibili ngithi kungaba ukuthi uthi R1 abe in parallel no R2 phinde abe in parallel no R3. Right, that is another possibility. Resistor, just giving you what I have of the circuit. The other possibility ngenza ukuthi ngithatha R1 abe in series kodwa R2 no R3 babe in parallel. Itefana nale. Noma ngizothi R1 ahambe yedwa then abe in parallel ku R2 no bani no R3. R2 no R3 ba in series. Right, so I have those 4 possibilities. Mangi phethe hlambe ama resistor awu 3. Masibuyela kule example yethu lana uno 6 ohms, 4 ohms no 5 ohms. We calculated sathola bani u15 ohms. Lana we calculated sathola 1.62, right, the total resistance. Ngoba kuno 6, kuno 4, kuno 5. So le 1.62 ohms. Now, when you have into engineer, this one, the main thing is to understand what is it a series or a parallel circuit. Njengoba kusuka i-current mayizosuka lana kwi-cell ize ala uzobona kuzoqala idlule ku R1 mase iyangala. So that is already what a series circuit. Lena so it's a series circuit with a parallel branch. Lena sekuyi branch. I-branch A parallel. So biza banu RP. It's a parallel branch. But the whole circuit is a series circuit. Right? So it's a series circuit with a parallel branch. Mawufuna ukuthola total resistance. Kalu calculate laba kala donc this total resistance usakhumbula ukuthi ama resistor u2 ma in parallel so calculate kanjani 1 over so zothi 1 over RP akuyona RT ngoba mawusebenzisa uRT kusho ukuthi usufake wonke ama resistor ngala sebenzisa la u2 kuphela. So it's not RT kodwa uRP the parallel branch uP for parallel or noma ngothi R uthi 2 the 2 parallel lines kusho ukuthi they are in parallel. So kuzoba 1 over R2 plus 1 over R3. Qala calculate uRP meseke uzo add ke lo R1 ngoba lo RP u in series na lo R1. Ngoba mesama ku reduce le circuit uzoba no R1 in series with uRP. Lo RP uphetheni uphethe R2 no R3. So that is how your circuit will be. Right? Then mesofuna RT so zoti R1 plus RP. That will be the total resistance ezohlanganisa R1 no RP. Kanti siyazi ukuthi ni RP khona bani? Kono R2 no R3. Then masibuka le resistance le connection. Right? I current izosuka kwi cell, then mesisuka kwi cell iya split angala iphindi hlangane ngala. That is already what? A parallel circuit. It is a parallel circuit. Kobo R1 is in parallel. Manje simona ukuthi laba u2 R2 no R3 banjani ba in series. So it's a parallel circuit with a series branch. So lo sombiza mobanu o RS. Lo uzoba o RS. So because it's RS, fawuqala ucalculate lo RS the branch ones. So ngoba usuhlanganisa u-R2 no-R3 kuzokunika bani u-RS. So i-circuit yakho simple like this, uno R1 then ngala suno bani no RS. Kanti uyazi ukuthi u-RS usehlanganisa u-R2 no R3, then you have that circuit. And sekulula ke makuthola i-total resistance of the circuit suzothi futhi 1 over RT ngoba in parallel 1 over R1 plus 1 over RS. That's how you calculate the total resistance of any circuit. Now, the other thing, fanele wazi ukuthi mawuthola total resistance of the circuit, fanele ube able to bona ukuthi current esuka kwi-cell, right, will be the same as the current that izobuyela kwi-cell. So you yakutshela ukuthi no, these resistors are connected in series. Akusiyo ukuthi fanele mhlambe wonke abe horizontally placed ukuze babe in series noma babe in parallel. Kungenzeka futhi like you have a circuit like this, u-R1 lo, then ube nobani no R2, right? Ungasho ngoba u-R1 uphezulu u-R2 uphansi kusho ukuthi they are in parallel. It's not about how they are arranged, but it's all about how they are connected. Into efanele uyibone ukuthi i-current izohamba kanjani. Current izobuye iqala ingene ku-R1 mase suka ku-R1 iye kephi ku-R2. Because of that, these two are connected in series. They are not in parallel. They are not in parallel. This is different maguti so wa connector lama resistors wa connect kanje. U-R1 or R2. Siyabona ke in this case into ebona ukuthi lo R1 uphezu ka-R2, but that does not matter. Into ebalekile ngala ukuthi i-current yona ihamba kanjani. Angithiwa ukuthi i-current izosuka la mayifika la iya split. By the time kuno split of current, that is a parallel circuit. So fanele unake njalo ama junctions afana nalo. So khona part of the current izohamba ku-R1, the other part izohamba ku-R2. Then when you have that like that, so you have what? Parallel. You have a parallel circuit, right? So that's it. Now let's have a practical example where so enzayibani application ka ama connection in series noma in parallel, right? Especially when we have a mixed connection that can be in series or in parallel. We have a cell, so R1 hlambe 6 ohms, then R2 bese kuno R3. Right, this is just an example. Kuthiwa voltage la 9 volts, right? Mese kuthiwa ke that the sine ammeter somewhere. Ammeter ufaka hlambe ammeter la u-A1 kuthiwa then this ammeter here reads a current ka let's say ka 0.5 amps. Kanti u-R1 u-R2 hlambe wona na u6 ohms noma sithi 5 ohms. Mase kuthiwa ithini resistance R3. What's gonna be the resistance R3? Right. Let's say the current, the current that will pass through the resistance 0.5. Now what's gonna be the current R3? Into fanele wazi ukuthi u0.5 i-current ehamba kuphi leyo current, because uzobona ukuthi u0.5 i-current izohamba throughout the whole circuit. The 0.5 yona current that was divided kuhamba ngala then ibuyele ngala, right? So you have what? The total current. 0.5 represent the total current of the circuit, right? Then mauna loko then uzobona ukuthi no, this one inga-assist ukuthi uze uthole i-current noma esithatha i-current ka 1,2 amps. Mhlambe leyo example izosebenzela kahle masithatha i-current ka 1,2 amps that passes through this circuit, 1,2 amps. Then what is the value of R3? What is the value of R3? We have 1,2 amps. Then in that case, itefanele sithole ukuthi sinendlela eziwu2 so calculate ngalo ngoba sinani i-total current. I-total current siyayazi ubani uzi 1,2 amps. Sine voltage, the total voltage u9 volt. Singasebenzisa mhlambe i-total current ne-total voltage sithole bani i-total resistance. Sithole i-total resistance ngoba sibona ukuthi this circuit is a series circuit with a parallel branch. Makunjalo siyazi ukuthi i-total current masi calculate sothi u-R1 plus u-R2 no R3 in parallel. R2 parallel R3 ngoba it's a series circuit so sihlanganisa u-R1 kodwa u-R2 no R3 they are in parallel kusho ukuthi siyakwazi ukuthola bani i-total resistance, right? Manje asikwazi ukuyithola ngoba asinawo R3, but enye indlela esingathola ngayo i-total resistance singasebenzisa i-total current nani ne-total voltage. So ngamanye amazwi masithatha ukuthi total resistance in this case uzoba i-total voltage over the total current. That will be 9 over 1,2. Right, 9 divided by 1,2. Sinika bani 7,5 ohms. I-total resistance yethu bani u7,5 ohms. Sithola ngani the total voltage ne total current u7,5. Right, mase sikuyela ngala nani ngoba sine total resistance. I-total resistance ubani 7,5 is equal to u-R1 siyamazi u6 plus sesisele nalo RP lo RP uhlanganisa utotal u-R2 no R3. So masi sebenzisa kahle sithola ukuthi u-RP wethu ubani u7,5 minus 6 unika bani 1,5 ohms. Kusho ukuthi u-R1 no u-R2 no R3 masubahlanganisa kufanele bakukhiphele bani u1,5 ohms. Then those two are in parallel. Calculate kanjani ama resistors that are in parallel. In parallel siyazi ukuthi 1 over Rp is equal to 1 over R1. In this case ngoba sebenzisa R2 no R3 so the 1 over R2 plus 1 over R3. Right, ama values siyawazi 1,1 over 1,5 is equal to 1 over R2. Siyamazi 5 plus 1 over R3. Right, then sebenzisa ke imath ukuze sithole the correct answer. So to 1 over 1,5 minus 1 minus 1 over 5. Right, then lapho sizothini sithole inverse ka 0,467. Right, 0,467. So tolobani ukuthi total resistance 2,14. That will be the R3. Right, total resistance R3. So it's all about how you go about ukuthola information that is missing. So in terms of ukutshela ukuthi make sure ukuthi uyakwazi ukuthola i-total current. Ngoba uthola i-total current izokusiza ukuthi uthole yonke into. The second method ungahamba ngayo ukuthi uthole i-voltage across the each and every resistor. Angithi series circuit i-current ihamba ngala sithi u-1,2 cause that is the total resistance. So kusho ukuthi ngathola bani i-voltage ela. Kanti i-voltage is the current times the resistance. That will be 1,2 times 6. Sinika bani 7,2. Kusho ukuthi lana kuno 7,2 volt. Makuthi kuno 7,2 volt and siyazi ukuthi series circuit is a voltage divider. Kusho ukuthi i-voltage across lo RP lo izoba 9 minus lo 7,2. That will be 1,8. I-voltage yala u-1,8. Now, mothola ukuthi 1,8 volt. Lama resistor awu they are in parallel. Into siyazi ukuthi in parallel resistors are in the voltage is the same. Kusho ukuthi voltage ngala 1,8 ne voltage ku R1 R3 also 1,8. Seshota ngani nge-current. Njengoba siyazi i-voltage across R2 kusho ukuthi singathola bani i-current. I-current yakhona will be 1,8 divide no 1,8 divide by 5. Sinika bani u-0,225. Then makuthi 0,225 amps iyona current ihamba ngala ku R2. Kusho ukuthi the remaining current esuka kulo 1,2 ihamba ngephi kulo R3. Then sizothini 1,2 minus 0,225. So that will be 0,975. So i-current ihamba to R3 u 0,975 amps. So siyabona ukuthi sine voltage ka 1,8 ne current ka 0,975. So siyakwazi ukuthola ibani i-resistance ka R3. So masi calculate again sizothola ukuthi it will be 1,8 divided by 0,975. Right, unika bani 1,8 amps. Right, 1,85 ohms. That will be the resistance R3. So nendlela eziwu-2 zo calculator unknown. Right, that's it. Right, now enye into fanele siyazi ukuthi masibuka i-electric circuit sibe able to redraw i-circuit ngoba sometimes abakuniki nje ama-resistor ukuthi ahambisana kahle. Then wena kumele wenze sure ukuthi uya understand ukuthi leyo circuit le imi kanjani. Right, sometimes you have into njena ke then ube ne resistor eyodwa ela nambe ube ne enye resistor esibili ehamba ngala. Right, into fana. Right, this is what it's a series circuit. Ngisho nje umbona ukuthi kumile kanje but it's a series circuit with parallel branch. Le resistor lo mhlambe soku R1 sithi R2 la no R3 no R4. U-R1 is in series kulama resistor 3 R2 R3 no R4. So kumele ube wena able to redraw the circuit. So into fanele uyenze suka la kwi-cell uhambe ngala. So uzobona ukuthi if this is a cell ngisuka la zoqala kephi ku R1. Bese ngisuka ku R1 kune junction la. Right, kune junction. I-junction yokuqala isisa ngala ku R4. So uzobona ukuthi uno R4 bese sihamba ngala ku junction kuno R2 ufake u-R2. Then after u-R2 khona enye junction u-R2 ikisa kephi ku R3. Right, this is how the circuit is. Kumele ube able ukwenza ngathi. Angithi uyabona ke kwi-exam bazokunika into efana nale, but when ufana understand ukuthi you can redraw it so that you understand it easily. Sengiyabona ukuthi u-R2 R3 no R4 they are in parallel kanti u-R1 in series masukuhlanganisa wonke lama resistance. Right, so namhlanje besifuna just ukuthi sibuyele ka grade 10 ukunikhumbuza ukuthi athina ama connection in series and parallel. So next time asihlangana futhi so faka ke indaba ka internal resistance and so base siqedela ke ngalapho. Right, siyabonga-ke, asibonane next time. Same place.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje. Enisethulelwe ngezilokotho ezinhle Ithala libambisene ne-Go Digital SA Foundation. Thamelani ke futhi esilandelayo ngesikhathi esifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.